Hi. Yeah, I hear you, and but this stream, this stream at the YouTube, it seems like it's recorded. It's not live. Ah, okay, I see. Yeah, yeah. I opened this hours thing. Yeah, A2OS examples. iOS tutorial. Mhm. Yeah, just just a moment. Yeah. Oh yeah. Uh, Magic core. 30 seconds. Well, nevertheless. The quality will suffer. I'm just cloning this A2OS again, so it will take like a couple of seconds because it seems like I just cloned the tutorial repository, and from this AOS A2OS I just downloaded one tar basic file to deploy the whole thing. Okay, so it's in progress. Uh, yeah, we have to. Our file system should be like synchronized or something. Okay, 80% complete. Mhm.
Okay, I'm going to turn on my microphone so that now don't listen to the stream, okay, because it'll confuse
Ah,
you.
okay.
But I'm turning on my
Yeah.
mic, but your voice will not appear on the stream. But my voice will.
Oh, I see. Yeah, yeah.
So there's no privacy problem for you.
Oh, I hear your like echo is delay in the background while stream.
Right.
So
Turn the audio off, like turn it all the way down on the stream. Because you only...
Yeah, I muted the stream.
Right, okay.
So I cloned the repository.
Okay,
A2OS.
all right, so go to the base of that, go to A2OS, CD A2OS, and git pull. I'm doing this. Okay, so it's already up to date. You should say already up to date.
Yeah.
Okay,
A2OS and
all right. Now, CD Linux 64.
Yeah.
LS.
Yeah, I got Bean A2SH extend Oberon.
Right, okay. So, do you have a directory named work?
No, it's just Bean at Linux 64.
Bin, yeah. Okay, so here the example. Now, you want to clone that example from GitHub, right? The AOS tutorial. Clone that.
Yeah.
Here.
AOS tutorial. Yeah, I cloned AOS tutorial. Yeah.
Okay, now rename that directory to work, small w o r k.
You mean rename AOS tutorial?
Right. Rename that directory to work.
Okay, done.
All right. So now CD work.
Yeah.
Okay. And ls.
It's configuration XML Turing to Turing PLL.
Right, exactly. And you can see. Can you see on the stream that I have something similar?
You did, yeah.
Okay, so
the work, yeah.
Right now the first. Okay, so now this won't do anything now, but it's a good habit to get into. So git pull. So now I can make a change, and you do a git pull, and you get it. All right. So
yeah,
this is inside another Git repository, which can be updated separately. I don't know if you've ever seen this trick before. Have you ever seen this before?
Already up to date.
So this is, it doesn't care that it's been renamed. All right. So here's the point. Now look at the stream and look at my ls for that directory.
Yeah.
Okay.
I have different files.
Right. What you'll notice is that you don't have configuration.xml.
I do.
In that file. Okay, well maybe anyway, you don't have the object files. Like
no object file.
Right. So the whole reason we did this is because now we can just say .. /a2.sh. All right. And just wait and look at the stream until we're synchronized. Okay?
Yeah.
We're synchronized. Now hit return.
Linux 64, yeah.
Okay, and...
Okay, I launched this environment. Yeah, blue screen popped up with the window.
Yeah. Now don't worry, I'm using a different windowing system than you are, certainly. I'm using Xmonad, so I have to start it in full screen. Okay. All right. So, okay, this is good. Now, let me teach you basics. Okay, you can look around in the Git repository, and you'll discover that there are object files in it for the whole Oberon system. But here's an important principle to remember. When the system starts up, it looks for object files in a path. And the current directory is the first thing it looks for. So that means that if you recompile a module that's part of the system, it exists on some upper level, the local copy will hide it.
Okay, I see.
So the first thing we're going to do is we're going to go to System on the menu in the lower left. Click System and click Configuration.
System and configuration.
Okay.
Yeah.
Now, what you'll see is that, do you have line numbers or not?
No, I don't.
You don't. Okay.
Just XML file.
Right, exactly. So now look at the stream. I have line numbers. See
You
that?
do, yeah.
Okay, so we're going to change your installation so that you have line numbers, okay?
Okay.
Okay, so what you're going to do is you're going to find a particular line in here near the end, and you're going to find it with a search. Let me see.
What should I look for?
Just wait. Ah, yes. Okay, look for, just do a find, which you can get with a Control F. Find, and find capital L-I-N-E, capital N numbers.
Line.
Right? And you'll come to a setting name, show line numbers value. See it?
Just show line.
It's line 414, but you can't see that yet.
Is this search case sensitive?
Okay.
Yeah.
Do you find it?
No, I'm line.
It's
yeah, show line numbers. It's false. I'm changing it to
change
true.
it to true. Okay.
And store.
And store. There's also shortcuts for store and compile and such and find. So I use Control S, Control H all the time. Control S saves and Control H compiles. So I just do Control
H compile.
Right, we'll get to that. So just, okay, so that's true. You stored it now. Now,
yeah.
Go to System, Save Desktop.
Save desktop.
Right? And now shut down because you want to open it again and have the changes take effect.
Okay, it shut down and I'm restarting it.
And you should have line numbers.
No, I don't. Line. Okay, gotta try it. Okay. So it seems like I changed it in the file called auth source configuration.
No, right. You have to store it locally.
Yeah. How do I do that?
Wait, you hit store, what happens? You change it, you hit store.
Yeah, and it says home. Yeah, it's it's not a local file. It's home directory A2OS source configuration.
Right. No, but you want the local version. So just save a file named configuration.xml. Right? So take off the prefix.
Okay. So I do store and I restore. Okay, now I got line numbers.
All right, good. So I just wanted to show you that because you might want to change that file later. and I don't want to share it over. Okay, so now, let's see. Okay, so now the next thing we look at is go to the lower left and files.
Files, yeah.
And files again.
And files, okay.
And you get a browser, okay?
Files manager. Mm-hmm.
All right, this is very important. Also, open on your desktop should be the kernel log.
Yeah, it's already there.
Okay, all right. So I believe everything on the kernel log gets echoed to the terminal that you opened it from. But anyway, so that's just okay. So file manager. So if you look at work, file systems just shows you the local directory.
Okay.
And if you look at Searcher, it shows you everything that's available in the whole installation. So go to Searcher.
Searcher, yeah.
And then on the right-hand pane, the text entry box on top, type in * capital MOD. And it filters the column. So that is all the modules that exist in the whole system.
Okay.
Including the ones in the local directory, work, because work is inside Searcher, I believe. But anyway, so now you can look at any code on the whole system. Okay?
Okay.
So you pick one and tell me what it is, and we'll look at it together. Any module.
Okay. I'm just checking whether it picked up the modules from the current directory. So I should be able to load this during PLH, correct?
Yeah. So don't worry about that. Just go to work. We'll go to work. There's only 2 modules in the current directory, right? But I just wanted to show you, this is where you want to look. This is where you look for any code for the whole system. And if you were to modify one of these files and save the object files in the local directory, like for instance, there's an X Windows interface, right?
Yeah.
You might recompile that in such a way that it couldn't start without crashing, right? And the local object files, so you wouldn't be able to start the system in this directory until you removed the object files. I wanted to warn you about that because you're going to run into this. You're going to do it.
But it should be evident from kernel log, I believe.
Yeah. But the point is that you'd still be able.
Some kind of exception or.
Right. I'm just telling you what you might encounter later, so you'll remember it. Now go to work.
Okay.
And open.
That's clear.
Open Turing.mod. Now the way you open is you highlight and you double click.
Okay, so it's I'm not seeing this Turing anything starting from Turing in the searcher.
Okay. Well, then it doesn't show work. But anyway, go to work and look at and open Turing.
There is no Turing in work. For some reason.
There's no Turing.mod?
No.
That's interesting. But
I got just 3 file names: auto.dsk,
right?
configuration XML, and bug file for configuration XML. Just 3
okay,
files.
So let me just check and make sure those are in the Git repository. So git status. New file, Turing.mod. Okay, git add Turing.mod. Git commit. Okay. Git push. Okay. So Okay. So that you didn't have that yet. Now quit out of A2 and git pull. Have you ever worked this way before?
Yeah. So I'm doing git pull, yeah. Okay, so you pushed it to AOS tutorial.
Yes, I pushed to it. So just get out, and your status line should say work. In that directory, git pull.
Yeah. Okay, when I do ls, I saw Turing.mod, Turing PRL.mod, and Turing tool.
All right. So
So I'm restarting the
right.
Oberon.
Okay.
And then I go to files, and work, and again I see this just 3 files. So it seems like it's some kind of file filter. Could be.
Well, you put the filter on top when you said star.mod. Right?
Yeah, but it's empty now.
Okay.
I mean, this filter string is empty.
All right.
And
so do you have any module files?
No.
That end.mod. So
it seems like it doesn't look at the current dir from which I started this AOS thing.
Well, it should.
It work.
That's what we're trying to figure out. Okay, so shut down and do an ls on this work directory.
Yeah, I got all these files that don't show up. By the way, I don't see configuration xml.back. Okay, let me see. It seems like it looks the wrong directory.
Right, because the directory has to be named work or it won't find it. Right? And you'll see why this is if you look at what a2.shell does. So it expects that particular name. All right?
Let me try one thing.
So if the directory is not named work, if it's named tutorial, it won't the files will not show up. It is looking, it expects you to work in the directory named work. And this is just part of the Linux script. I mean, I could change it.
Yeah, I got it. So the work should be in Linux 64.
Right.
This is the reason. So okay, yeah, now it's clear.
Okay, so let me give you some background on the system. Okay, so in Oberon, commands are run just from text. So any place you see text, there's a possibility that you can run a command. So can you open one Turing.mod?
Just a moment. Okay, I recreated. Yeah.
Okay.
So what I, now it's,
Tell me when you have the module open. And I'll start teaching you about how modules work.
so I go to files, work, and now I got this Turing model, yeah.
Right, open the module. So the way you open it is just by clicking.
Do I need to open Turing key? Okay,
Select it
it's
and then
open
click.
now. And
Okay.
these line numbers.
Right. Okay. So let me teach you. First, the first line of the module is module, name of module, semicolon.
Yeah.
All right? Now go all the way to the bottom of the file. Do you see the line that says end Turing, end name of module, period?
Yeah, and Turing period.
Right, okay. So the module, as far as the compiler is concerned, the module begins with the first line and ends with that end name of module period. Okay? So
Okay,
everything.
so it ignores everything.
Right.
else.
So everything past then is just text for you.
Okay.
All right. So it's common in modules to put a little tool text afterwards. So if you merely go to, say, Turing.open, see that line? Okay? And if you middle click, so with your mouse wheel you click, middle click on that. I assume you have a 3-button mouse.
Middle click, yeah.
All right, you see the red line that appears underneath it? The text is highlighted by a red line.
No, it's middle click. Okay, it's probably due to settings of my window manager. It just opens a context menu with cut and paste.
Ah, no. You needed to pass the window clicks on, or it's not going to work, because you're going to need middle click.
Okay, I gotta figure it out probably.
All right, you want to take 5 minutes for that?
I don't know. So, okay, please show me what should I be getting with this middle click.
You should be getting have a look. You should be getting a
red line underscoring.
A red line underscoring, and then it will do the action that's specified. Now, for you, it won't do anything because you don't have any object file associated with this module yet. You haven't compiled it. But you can see when I click, I get a red line, and then when I release the click, I get this. There's a delay. Just wait.
So it's like a context command to open, to execute the file.
Right. Do you see?
Yeah. Well, if I wouldn't be able to figure it on the fly, is there a menu alternative to just execute it?
No, this thing where your operating system's stealing mouse events, I can't. I don't know.
Because it's probably it has to do with the either window manager or the configuration of X server.
Right. It has nothing to do with the Oberon operating system, though.
No.
I'm saying
it's underlying stuff.
Right. But I can't help with that. Do you think you can work on that quickly? Because it's impossible to teach you this stuff without the middle mouse button. Well, is that really true? Let me see. There may be.
Can I do something like compile and run, or I don't know, open?
You need the middle mouse button, but let me see. Oh. There may be a substitute for it. Let me see. Desktop. Okay, so go to docu down in the extreme left corner and go to the tutorial, and it will tell you about desktop navigation. So text editors, mouse commands, selection. Okay, it does not look like there is a key. Right, but yeah.
Okay, I need
okay,
to
wait a sec. You can use Control Enter instead of the middle mouse button, I think.
Yeah, I pressed Control Enter and it started, yeah.
Okay, so you might, does that work for you? It doesn't work for me. You can.
So it executed, yeah. So it works, and I'll try.
Okay, but you don't have any object file yet for that module. So you haven't compiled it yet, right?
But nevertheless, I got this window like with this.
That's because there's a module of that name that's already in the operating system. It's one of the demos, right? So go up to the top of the file.
Yeah.
Module import const. See that? Const? Yeah. Okay, so the size of the array is determined by the constant m. So just change that. Or in fact, don't change it. It's 500, right? Okay, so all we're going to do is we're going to use the compile button on the top. And your status window at the bottom, your status pane says compiling Turing done, right?
Okay, which value should I put to this size instead of 500?
No, 500 is fine. Just compile.
Compiling Turing done.
Right. Now, this is very important what I'm going to teach you. Now, run it. Turing.open. And you'll get exactly what you got before.
Open and Control Enter, and yeah, it's exactly the same. Yeah.
Right. It's not the 500. Okay? So stop it again.
Stopped.
All right. The reason is that there was object code for that module name resident in memory of the system.
Yeah,
so
that's clear.
When you recompile, you create a new object file, but it's not going to load the new object file because it already has an object file for that name.
Well, maybe I can declare it with other name like Turing1 or something.
Not necessary. System.free Turing. Right? Free. Do you see where it says that? System free Turing? Down by where you clicked, by Turing.open. The line above it is system.free.
System free, yeah.
Yeah, execute that. And now the object file is not resident in memory. Now open Turing.
Okay, yeah. So I launched it again.
And now it's different, right?
Not really. Okay, what should I change in the code to make sure that it's
okay, you get a little fast window or a big slow window?
It looks like, you mean after the execution?
Okay, look at the stream. This is why we have this stream. So look at the stream. I'm running something that hasn't shown up. Okay, that. See it?
Yeah.
Okay. Does yours look like that?
Yeah, exactly.
Okay, good. All right. Now, let me say something. If you free now, this window will disappear. But it's possible to crash the windowing system, and it's possible to crash this whole A2 window if you free a running module that doesn't have a correct cleanup module. You see the procedure cleanup?
Cleanup.
Right. So if that was not there, then you would crash the whole A2OS with the freeing. You have to be very careful when you're freeing a running module. But in fact, so just go up to the top and change it to M is equal to 200, size equals 2. And Control S, Control H to save.
So M is 250 and size is 2.
2. Right, 200, 250, what, 250? Okay. And S, Control SH.
Yeah.
And you should get, it should say, do you see Turing, TCW, see that green in the stream and the error messages?
Yeah, it's like redefined.
Right. Okay. So now, system free Turing.
System free complete. Unloading Turing done.
And open the new one. Wait. No, it's...
Okay, I opened it and it's a little bit different, yeah. Oh, I mean the pattern are different.
Right. Well, this is
So
really...
Indeed, it seems working.
Right. So that's the reason I selected this as a demo, because it's easy to change. Okay, so now you can look at the code. Leave it running and make that... see if you can change the size of the code window, because we're really going to want a bigger...
I see. So if
So see if you can make that big, like I'm doing here. Okay. Okay. So you go to procedure generation.
Just a moment.
Okay. Well. So you can see the procedure and new. Basically, the only procedure that you would change code in to change the way this behaves is generation.
Procedure end of draw close the generation. Yeah. Okay. Yeah. Procedure generation.
Right. So this is for you to play with, like you can work later on this. For instance, we see where it says, here are the difference rules.
Mm-hmm.
So if you look at the constants there, you see the constant 80. You could, for instance, let's change that constant 80 to 50. Do you see that?
No.
There's a line that says, here are the difference rules. The next line is
okay, I have 80, yeah. I can change it 80 to 60. Yeah.
To 50. Just do that change, save, compile.
Compile and load consultant.
Free the old one, system free, and open.
Okay, it looks different.
Right. I'm getting very different behavior. So what I get is that it changes to, yeah, this is very interesting. It can get more complicated. For instance, the rules can refer to, okay, can you see my stream?
Yeah.
You see that?
Yeah, I'm getting the picture is very similar.
All right. So I could go to one of the rules, like that rule where I changed the 80 to 50, and add a term. So at the end, I can add a reference to I. So let's see, I is running between 1 and 250, so all right. So you can just see the code changes I've made there. You'll see them in a minute.
It's plus I. Plus I is 2,500.
Right, so what I've done is I've introduced, the position of the cell being considered, the I position is now included in the. So I'm just saying this is a.
Yeah, I'm getting the same pattern of vertical lines here. I just replicated the change.
Right. So I'm saying you can explore all kinds of behavior with this very simple model.
But what it really does?
I
mean, this Turing, it's the implementation of what?
It's just basically it's something I invented. It's basically Life, John Conway's Life. John Conway, much respect, just passed away.
The game of life, yeah.
Right. So this is basically a real valued analog of that. So there's a procedure neighbors, which counts up basically it sums over the neighborhood. Procedure generation, before the difference view. See, before the difference rules, there's all that summing. Right? So first this is good though. You keep it running and you see the pattern is getting more complicated than just lines.
So we can say that's an example implementation of procedural generation in Oberon.
Right, exactly. Right. So I just want, this is very low level. I just thought it would interest you because it would show you, it would make your mind start working on how you could do things. Now, do you see the interesting, look at the stream. Look at the behavior I'm getting.
Oh, it's something like an interference pattern on the left.
Yes. Well, Alan Turing was the one who he wasn't just a computer scientist. He also wrote a paper about animal coat patterns and developing in embryogenesis through the reaction and diffusion of two separate chemicals. So this is sort of a simulation of that.
Yeah, just 2 days ago I was refreshing my mind on Jacobians, how they work.
Right. Well, I've never worked with Jacobians, but the point is, we need Jacobians for this. We can write a module to implement them, or someone may have already written a module. So the first thing you should do, okay, so let's close that. The first thing you should do, okay, so go to Searcher in Files. Oh, in fact, don't do that. Go to Tools in the menu. In the menu on the lower left, Tools, Search, right? All right. So the path is Searcher. We're looking for module files. The content you want is just Jacobian. So we'll see if that string appears anywhere, and just hit go.
No.
Nothing.
No.
So try matrix.
Matrix here, a bunch of files. Well, it's not working for me now, but anyway. The point is that's... No, I got a bunch of files with metrics inside here.
Right. So you can look at all that code and decide if any of it's relevant to what you want to do.
But you are saying that these files, these modules that I just cloned with the A2OS is a pretty comprehensive code base for Oberon.
Yes.
Is it true?
Yes. All the files are there. So now what I want you to do is go to Work in the File Manager, right? And look for your object files. Now there's now there are two, this sim and GOF. I don't understand that, but the file format changed like a year or two ago to these. So
I got two two files. It's Turing.gofu and Turing.emu.
Right, and I'm trying to see if I can open these, because you should be able to open the symbol files.
It's a binary or something, no?
Yeah, but you can open them in edit text, right?
Funny thing, that middle button is working in the file manager.
Oh, really?
When I click middle button, I get open, rename, duplicate, and the same stuff like you.
All right, so open the sim file, SYM file, with edit text.
Yeah, and it's
so basically this
text.
So basically this is what you would get from a .h file in C.
Yeah, it seems like header, yeah.
Right, except it's automatically generated from the source file. Right? So you don't need an H file. So I have no idea why C does it that way. Right. So you should be able to open that object file with
You mean GIF?
Yes, you should be able to open that and see it and see the code, but for some reason it's not working today. I guess I'm not really sure what's going on there. But there should be
when I open it, it's binary.
Okay. There should be a disassembler view.
Disassembler. It's not there, I believe.
Yeah, but I don't have that today. But anyway, I'm trying to give you tools so you can explore this when I'm not here.
Okay, so it's clear for me now how to load models and execute and introduce changes.
Right. Okay, so maybe I should just let you go now and let you play with it on your own for a while.
Yeah, anyway, I got just like 5 or 10 minutes left.
Okay.
So, yeah.
So but you're set up to be able to do stuff on your own. So what do you think so far? Okay, so the speed is the same as C, right?
Well, likely, yeah, likely.
The speed
So
is this.
if it compiles to an object file and executes it directly without like interpreting or stuff like bytecode, it should be the same.
Right, right. So I think, so my question, the point is, I'm trying to convince you that this is a good environment to do this project in.
Well, what can I say? First, this language seems obscure to me, but it's just because I
Yes,
okay
it is obscure, but
I can tell you that it sort of looks like Fortran. I started my first programming language was Fortran for some kind of reason, and it was like I don't know 30 years ago or something like that. So.
yeah, but the point is, this is much easier than trying to write code in C or Rust. And let me tell you something: C, C++, Rust, Haskell, none of those have a real-time ray tracer written in them, right?
That means yeah, they are too slow. Yeah.
Well,
I mean,
no. No. I wrote a real-time ray tracer that could be ported to them, but none of them have it, right?
Mm-hmm.
So,
Yeah.
in a certain sense, the most cutting-edge graphics research is being done by me in this environment and language. Okay?
Okay, so my comments about the syntaxes of this language are not quite relevant to the fact whether it's good for this kind of projects or not. What I need to check,
The point is,
will
you can.
research this
The thing about this
example.
is that you'll be able to understand most of it, like hold it all in your mind, right? The difficulty
Yeah.
with working with Python and OpenGL and TensorFlow, and it's like there's all this stuff and you don't understand it all, right? This is,
You're not supposed to understand it. Yeah.
but this is more constrained. This is so when I said, oh, there's an algorithm I can do machine learning in software now. If it's in software, CPU software, then I can understand it and change it. Right?
Yeah.
So
That's correct.
I think it's much better. And if I can get you to spend a couple hours a week on this, so much better.
Let's see. So what I want to do first, I got to do some research on Oberon, whether it has the language has built-in mechanism for stuff like multiplication of matrices, etc., which is important. Like this capability is quite important to do to implement any kind of algorithm.
Oh, right. Okay, so first of all, yeah, you've heard of BLAS?
BLAS.
Yeah, it's some BLAS.
No, nothing comes up.
Yeah.
Basically, linear algebra.
Right. So I know that BLAS has ported to Oberon. I'm not sure where it is. I'm not sure if I don't think it's in this system, but I know that stuff has been ported.
Okay, the second thing that let's assume that it's there, it's an Oberon.
But anyway, that doesn't matter because matrix stuff is easy to write if we know the algorithm we need.
Yeah, that's my point. The second point is that we need to look up for some reference implementation of simple, I don't know, gradient descent optimizer, which is written not in TensorFlow, not in Python, but in some primitive language like C, for instance.
So the GitHub repository for that slide project does not count?
It could be because this is what these guys did. They implemented an Adam optimizer, which is like a variation of gradient descent optimizer in C. But
right.
I spent maybe 30 minutes looking at this code of flight, and it's how to say, it's too convoluted for me to clearly understand it at the first.
Right, because it's in C. But I will tell
Yeah,
you
it's
how
a
to.
nightmare.
But can you figure out? Just because it's too convoluted to understand in C doesn't mean that we can't recreate it in Oberon.
Yeah, I need to find some, I don't know, PowerPoint slides of like, in block scheme, this algorithm of gradient descent optimizer, which matrices it multiplies, divides, or whatever, because as you say, in TensorFlow, we don't think about this kind of stuff. We just call matmul operation and everything.
Right.
Everything is
Okay,
getting done.
so do look at BLAS because
BLAS.
I know that I can find code for that. All that stuff.
But it's not in this code base in A2OS.
I don't think so, but I know it exists somewhere in the Oberon. It's been ported.
Okay, so let's explore this first, and this got to be our, how to say, like feasibility study, or whether it's possible to implement this, simple neural network.
Oh,
otherwise we have to write this code by themselves.
But I'm saying the matrix code. Have you ever written matrix code? So it's just math, which means you don't have to understand it. You just have to be able to write it. And if it works once, it'll always work.
Well, yeah, it could be, but it's okay until you have to debug, things that don't work for some kind of reason.
No. The algorithms for this stuff are well known. It's very easy to implement underlying math stuff.
That's true.
It's easy. But convince yourself of this by playing with this Turing example, right? So just write some code. Play with it. For instance, let me give you an example. If you look at the neighborhood code, so you'll notice that it has coefficients like mesh 1, I minus 1, m minus 1. So it's looking on the diagonal. It's using the 8 neighborhood of the cell, right? So you might ask yourself, what if I just look at the 4 orthogonal neighbors and not the 8 neighbors? What difference does this make in speed? What difference does it make to the way the patterns change? So what I'm saying is you can play around with that. Right?
Okay, yeah.
So just do that. Then you'll be much more comfortable with writing matrix code. You just write some stuff. Just work on this generation, that procedure. So what you see is there are 3 big for loops, 3 nested double for loops. Well, basically, first you're taking care of the boundaries, and then you're doing the core. Because at the boundaries, you either have to wrap or not wrap. It'll be easy.
Okay, yeah.
It'll be easy.
I gotta try this, some changes to this example.
So let's have a short call tomorrow, not to do this, but just to figure out if you've got any, if there's anything you can't figure out how to do that's slowing you up. So let's talk shortly, just a short call tomorrow, okay?
Okay, but it probably gotta be not tomorrow, but on Wednesday, because tomorrow I'll. Yeah, I won't be there.
About the same time on Wednesday.
Yeah, more or less.
Thank you very much. Thank you very much.
To work from my office, the internet is much better because I can see your stream and we can talk and
right
without delay. Okay, and thank you for explaining the stuff.
Yeah. I hope. But anyway, the demos. The demos, I wrote Turing and the ray tracer, and they put it in. But that's a very old version of the ray tracer, of course. It's about 12 years old.
Yeah.
Nevertheless,
Okay.
you're on your Threadripper, right?
No, it's Intel.
Okay, so my point is that you can use top or htop to look at your cores in a terminal window in Linux.
Yeah.
You can look at the cores. If you look at the cores and then run the ray tracer, you should be able to see the core usage.
Yeah, I can confirm that all cores are loaded or non-cores.
Right. So the point is 12 years ago, before there were any massively multi-core CPUs, when there were just like 2 or 4 cores, right? I wrote code that still runs and uses all the cores.
12 years ago, I believe we used SMP, like separate processors, but not cores.
But this code works. I parallelized this code back then, and it still works. So that's pretty impressive.
It's great.
What?
It's great, and it's also great that this execution environment handles the multiple cores well.
Oh yeah, and if you go inside that Sierpinski cube, you can find along one axis there is little planetoids. You see that? Little black and white planets? Dust?
Dust, yeah, like emanating from...
Yeah, I believe that's a fractal. So the way it works is the rays to visualize are just stepping through a data structure in main memory. Right? So if you think of like an octree of nested boxes, basically, right? So in order to make a fractal, all you have to do is have a given link to main memory in different places in the hierarchy, right? So you have something that's part of itself. Right? So you can directly visualize a fractal. Does that make sense? So I could take...
That makes sense. I wish we would have a way to visualize stuff from layers of networks in GPU cores. That is, no, it's not possible.
Well, but the thing is, I can do things on the CPU that I can't do on a GPU.
Yeah, it's
right? Because what a GPU cannot do ever is step through main memory and handle it along each ray differently.
No, it's not designed like that.
Right. So my point is here I'm giving up something and getting something by using CPU.
Yeah, so it's a trade-off. Okay, so I'm disconnecting now.
All right. Oh,
and then let's plan for Wednesday, approximately around this time.
Right. Well, I'm sorry that nobody will collaborate with me, but this has been really fun. And even if you don't come back, I'll still treasure this memory.
Okay, but I believe I will come.
I hope that's true. All right. Thank you. Bye.
Anyway, have a nice day. Yeah.
Bye.
Bye.